Hello all, welcome to the session on creation patterns. Today we will see the basic creation patterns which are a building block for the other two design patterns called structural patterns and behavioral patterns. Why do we need a creation pattern? As I said, these are the building blocks for creating any product. They give you an abstract way of creating a new object. They will not give you the complete implementation. Rather, they give you a skeleton of creating a basic building block of any product. They help you make a system independent of how the objects are created, how they are composed in, and how they are represented to the outside world. We also have a clear separation about how do we make concrete class implementation and how is that going to be used by a system. We also can hide instances of the classes of creation and also how are they combined together. We can basically classify them as class creational pattern and object creational pattern. A class creational pattern differ the part of object creation to subclasses, whereas object creation pattern makes the creation happen by another product. We can see the different patterns available in both the categories. We will see one by one. In these patterns will focus on the object composition but not on the class inheritance. They also provide you flexibility in what we are going to create, who is going to create it, how are they going to create it, and when is it going to be created. The configuration can be static or dynamic. It depends on the runtime configuration of the product which you are going to use the pattern. We will see the abstract factory first. The very basic intent of an abstract factory is to provide an interface for creating families of related products or which can be dependent on each other, but we are not specifying how the concrete classes are getting implemented. This is also known as a kit. Let us say, for example, we have different look and feels for user interface. We can have different look and feels defining different appearances and behaviors of UI components and widgets like buttons, windows, scroll bars, etc. These should not be hard-coded. So what we can do is create an abstract widget factory interface for basic widget creation, and we can have concrete classes that will provide specific implementation for specific standards of look and feel. We are revealing only the interfaces but not their actual implementation. This pattern is used and we want to have a separation between the product's creation, their composition and the representation. And also we can have multiple families of products which can be designed and used together. The subclasses of the concrete factory can be made by the concrete product classes. And for a simple application, there will be only single concrete factory instance. That is how you use your singleton instance. A singleton is one where for the complete project only one instance is allowed. So for this per product family also, one instance of concrete factory is allowed. We can use factory method to create each product. The difficulty in this is to add a new product because we already have defined the interface, we already have written the concrete classes. So in order to provide an extension, what we can do is we can use concrete classes, and an alternative way is to add parameters to the operations for creating new objects. The consequence is we can have isolation amongst concrete classes. We can have exchange or exchanges of products from one to the other. We can also exhibit consistency among the product development. We can implement the factories as singletons, that is one instance only can be created. We can also create products. We can also define the factors which can be extended using these implementations. Interviews and AT++ use these design patterns already. The prototype is also used to create some concrete class implementations. The singleton is already used in concrete factory. Coming to builder, we know the meaning of a builder which gives you a construction at a higher level. So in our case of design pattern, the builder pattern is intended to have a separation between the construction of a complex object to that its representation, so that from the same building blocks we can have a complex infrastructure that is a composition of small components. Let us say we have an RTF document which has to read data and also export it to different file formats. The RTF reader, the basic purpose of RTF reader will recognize the RTF tokens. Once it scans and identifies the RTF token, it will pass on the RTF token to a text converter. The text converter then converts that token to a representation format basing on the target application and its compatible format. That is, the object is the same, the representation of that token is going to differ depending on the target. It is applicable when to create a complex object, how do we make the process different? Because how do we combine the objects? How do we get to the end product? By a combination of all of them, or the assembled to make a complex product from the basic building blocks. If you look at the structure, we have components called builder, concrete builder, product, and a director. A client will directly talk to the director and ask you for construction of a product. This is your interface where a user can communicate. The ultimate result is an end product, which is a combination of all the individual components. This director will gives you a communication to the builder, which has an interface. The builder provides an interface for creation of the parts of a product or a complete part as a whole. This build part interface provides you a means for building the complex components. Then this builder is going to call your concrete builder, which constructs and assembles the part of a product. This product is a complex object under construction. It will build the internal representations and also it will make your assembly possible. So once these are done, the final product is going to be delivered to the client. It is going to be done. Individual parts are also built and they are assembled together to form a complex structure. The abstract factory and builder are similar. The minor difference is builder pattern is used when you want to build a complex object, whereas abstract factory is used when you want to build families of objects which could be simple or complex. If you look at the collaborations also, the client creates the director object and the configuration is done by the client only before the builder is going to call the product. The director notifies the builder whenever a product has to be built. The builder allows you to have different representations internally. It also separates you code for construction and a code for representation. We can also have a finer control in the construction process because it is loosely coupled. We can implement assembly and also construction separate interfaces. We can also have pure virtual functions that have different methods for the product building and the product composition together. RTF and parser also will use the builder design pattern. The abstract factory is used along with builder. Similarly, composite pattern is used to combine multiple components to form a complex structure. Thank you.